Hey guys, it's Bethany. So maybe you've heard of the Monty Hall Problem. Well, this problem gets its name from a game show called Let's Make a Deal that aired in the 60s and 70s. The name of the game show host was Monty Hall, so no shame if you haven't heard of it because it's the 21st century and cable TV is barely a thing anymore. Well, the Monty Hall Problem got really famous when someone asked Marilyn Vos Savant, the smartest woman in the world at the time, this question. Suppose you're on a game show and you're given the choice of 3 doors. Behind one door is a car. Behind the others, ghosts. You pick a door, say number 1, and the host who knows what's behind the door opens another door, say number 3, which has a goat. He says to you, do you want to pick door number 2? Is it to your advantage to switch your choice of doors? Well, she answered yes. It is to your advantage to switch doors. So basically, in the problem that Marilyn Vos was given, the game show host would show the contestant 3 different doors, and behind one of the doors was a shiny new dream car. Now, the contestant had to pick one door. Then, once the contestant chose a door, Monty Hall would open another door. The door he opened always had what was called a zonk behind it. After he revealed a zonk, the contestant then had the option to switch to the only other door or stay with the door that they chose originally. At this point, almost every contestant would experience high anxiety and not know what to do. But they would almost always stay with the door that they chose first. I mean, stick with your gut, right? Wrong. The problem in this case, in sticking with your gut, was that you were actually choosing lesser odds. Here's how. Monty Hall says, hey girl, which door do you think your sweet new ride is behind? And so the contestant chooses a door. Let's say door 1. Without opening the door that you chose, Monty opens up one of the doors that you did not choose. Since he's the game show host, he knows what is behind each door. So he always opened up a door that the car was not behind. That was called a zonk. A zonk always had something stanky behind it, like a llama, alpaca, donkey, or a goat. After he opened one of the doors, he then asked the contestant, do you want to stay with the door you chose or do you want to switch? This is when the contestants began getting really anxious because now one of the options has been eliminated and they know that their dream car can only possibly be behind one of the 2 doors remaining, which is true, so then it would seem as though the contestant now had a 50-50 shot at getting the car. So whatever, choose door 1 or choose door 3, who cares? Thanks, Monty, for increasing my odds, right? Wrong. In fact, if you switch, your chances of getting the car is increased. How? Well, think about it like this. If you switch, the only way that you can lose the game is if you chose the door with the car behind it on your first try. But remember, the odds of choosing the door with the car behind it on your first try are 1 in 3. So this means that your odds if you switch on the second try are 2 in 3. When you switch, your chances of winning are doubled. Perhaps you're still thinking, okay lady, it doesn't matter if you switch. Once he opens the door revealing the zonk, there are only 2 other options, therefore making your odds 50-50. Boom. Easy. Get out of my face. I'll say, it is a little counterintuitive, but bear with me. Let's look at this a different way. To do this, let's split the doors up into 2 different groups. Group door you chose and group door you did not choose. Pretty straightforward, right? The only door in group door you chose is the door you chose originally, and the doors in the other groups are the doors you did not choose. Well, when all the doors are closed, we can easily tell that group door you chose has a 1 in 3 chance of having the car behind it, and group doors you did not choose collectively have a 2/3 chance of having the car behind them. But each door within that group still have a 1/3 chance. Well, once one of the doors is opened by the host within group doors you did not choose, you've now acquired a new piece of information. You now know that the car is not behind one of the 2 doors in the group doors you did not choose. Well then, what happens to the 1/3 chance that went with the door that got open in the doors you did not choose group? It can't just disappear into thin air. It has to be applied somewhere. The reason it can't just disappear is because the total chances when winning a prize always have to add to 1. If the 1/3 chance from the door that is now open just disappeared, then the total odds of winning the prize would only be out of 2 and 3, and that cannot be. So the 1/3 chance has to be applied somewhere. You can't add it to the door in the door you chose group though, because you haven't discovered any information about that group. You've only discovered information about the doors in the door you did not choose group. So the 1/3 chance from the door that was open gets reassigned to the other closed door in the doors you did not choose group. So now the chance of winning the car by sticking with the door you chose is 1/3, and the chance of winning the car by switching to the only door left in the doors you did not choose group is 2 and 3. That is the Monty Hall problem. However, on the actual show, Let's Make a Deal, when the contestant chose a door, Monty Hall never showed them another empty door and gave the contestant the opportunity to switch. They chose a door and Monty Hall offered them money. There was none of the switching business. Marilyn von Savant simply proposed the situation in a magazine article at the time, and the problem became known from that point as the Monty Hall problem, but in no way reflects what actually happens on the show. I hope that this video has been helpful. If you enjoyed it, be sure to hit that like button and subscribe to our channel for further videos. See you guys next time.